Hi and welcome to this video about volumes and symbolic links and a few other things in between. So what are volumes? Typically we think of volumes as partitions. So these are device objects created by file system drivers like C:, D:, things like that. This is typically how we work and interact with volumes. But in fact, this is not necessary. Volume objects are distinct objects that don't have to be pointed to by these drive letters. In fact, these drive letters are a particular case of a symbolic link or symbolic links. And these point to these device objects. So these are not real fundamental pieces of Windows. Sometimes we think that these drive letters are very fundamental to Windows, but in fact, they are not. So let's take a deeper look into these symbolic links or volumes. So one thing to try is maybe we can look at something like Notepad and see what happens if I try to open a file called whatever in some drive, say C. So let's go ahead and run Notepad. It's already running on my system here. I'm going to use the WinDbg instance here to attach to it. I'm going to use attach to process here and then look up Notepad. Should be here somewhere, and attach to it. Once we attach to it, I would like to set up a breakpoint in the function ntCreateFile and also create file. So let's start with create file. It's in kernel 32. We can call the function createFileW. We want to use the Unicode version because this is the version being invoked by Notepad, and in any case, even if you use the ASCII version, if Notepad uses the ASCII version, it will just convert the string to Unicode and call the W version. So let's start with that. Here's the breakpoint, and let's use Go to let Notepad continue execution. So now let's go ahead and open a file in ctemp, for example, here. So I'm going to take some file and open it, and we should hit the breakpoint. And we hit the breakpoint right here. We can see the call stack. We are at starting with the main of Notepad here. There's some stuff going on in big Notepad. It invokes the open dialog box with some internal private function, and then at the end of the day, createFileW is being called. Now, one thing we can do when we break at a particular function is look at the parameters of the function. And the createFile function is a documented Windows API, and the file name that we provide is in fact the first parameter. This is very well documented. So how can we look at the first parameter? We can use the fact that this is an x64 process, that is a 64-bit process running on an x64 system, and we have one calling convention for that, and that calling convention specifies that the first parameter is passed in the RCX register. So we can look at RCX using the R command, for example, or directly just dereference that as a Unicode string, and that's using the DU command. This is for display Unicode, and we can just grab the value of the register without having to actually copy paste its value by using the add symbol here. So you can see that indeed the file is ctemp.info.txt, which is the way we provide file names to documented Windows APIs related to I/O, such as the createFile function, which is used to create or open a file, but not just a file actually. And so what I'm saying is that this C column is really just a symbolic link. How can we prove that? So one way is to add another breakpoint into ntdll, into the native API called ntCreateFile. That's the real function that is going to be called by createFileW here before the transition to the kernel happens. That's a system call really. So we can set up this breakpoint. When we use the go command, we expect to land in this function very quickly in the same thread. In fact, we do. And if I use K here again to look at the call stack, we can see that createFileW has called an internal function called createFileInternal that in turn called ntCreateFile. So now ntCreateFile is tasked with doing the real work. Well, but what does ntCreateFile look like? So this is an undocumented function in general, but in fact it is documented in the Windows driver kit, and we can leverage that. So you can see this is ntCreateFile. I'm not going to go over the many parameters it has, but I want to just focus on one parameter, which is the file name. I want to see how the file name is being manifested here just before invoking ntCreateFile. So looking at these parameters, you might feel a bit bewildered because we don't see anything here that looks like a file name. There doesn't seem to be any string here anywhere. We just have some handle which is supposed to be the return type, and then the return value here, and then we have the desired access to access the file and other parameters. In fact, object attributes here is the little secret that works with most Windows native APIs, where strings are being stored for named objects or names need to be passed, like in this case. So this object attributes actually has a Unicode string structure representing the name. So this is the third parameter. And we know in the 64-bit calling convention, the first 4 parameters are passed using registers, which are RCX, RDX, R8, and R9 in this order. So in this case, what we care about is the object attribute structure, which I hope to find here. And if not, we might have to let the debugger figure it out. Because it might be defined in a different module, doesn't really matter. So I want to look at this structure. And specifically, I want to take the value there of R8. So that would be the third parameter there. If we do that, and it says, well, object attributes are not defined, so we might need to do some searching here. I think we can find that in COM-base for sure. So let's go ahead and let the debugger figure it out. I think it's going to work out fine. And here we go. We get the data structure here, and we can see the object name, which is the file name in this case. Notice what that looks like. It has this prepending of this backslash, 2 question marks, and a backslash. Because internally, Windows works with native paths, which start with a root directory, which has the name of simply a backslash. We can see that kind of stuff using a tool from sysinternals, for example, called WinObj. So let me launch WinObj now to show you that. This is WinObj. In fact, I think I've shown some of this stuff already in previous videos, but I want to focus on symbolic links here. So let me rerun WinObj with admin privileges so we'll be able to see everything there is to see. Here it goes. And if you look at the global 2 question marks directory, this is exactly where all the symbolic links are that are accessible directly by the create file function from a user mode. And so we can see things here like C colon and D colon. You notice that these are just symbolic links. It's not a fundamental object, so to speak. It's a symbolic link object pointing to something else here. In this case, device hard disk volume 3 for C colon, D colon is pointing to device hard disk volume 7, and so on. So this is in fact what is happening behind the scenes, and you can see the native API, it starts with a backslash and then 2 question marks. It's called here global 2 question marks, but in fact it is just 2 question marks in practice. So you can use just 2 question marks, and this is what happens exactly here. So when we specify normal drive letter from our perspective as just normal Windows users, the API, the create file API here in this case prepends this backslash, 2 question marks and backslash to indicate to the IO system in the kernel where it actually needs to go, because using just C colon will not work. If you try to call NT-create file yourself or NT-open file, it will not work with C colon. You have to use something like this, or you could use the real device name like device hard disk volume 7. You can do that instead of using a drive letter, because sometimes there is no drive letter for a particular volume. In fact, we can see that using a tool that I'm going to run here from the command line that has administrative powers called FLTMC. Normally this tool is used for working with the file system mini filters, but also has some general capabilities which are useful, such as looking at the list of volumes on my system. So looking at this list of volumes, you can see that some volumes, you can see they all have these some kind of device name. Some of them do have a DOS name, which is not really related to DOS at all, but this is just a relic from the old days, just saying there is a symbolic link for that. But you can see there are other volumes here that have no symbolic links right now attached to them. which is fine. It's not really necessary from a system perspective. If I would call the NT-create file or NT-open file APIs directly, that is the native APIs, I can specify these names and they would work. That is, they would be recognized by the I/O system. Using a drive letter is just a convenience that is very well known to normal users of Windows. So one of the questions might be, can we create these mapping ourselves? Can we map some device into a drive letter for easier working with that volume? Maybe I'm interested in this volume here that has a fat file system, which is perhaps a bit weird. Maybe you want to see what's in that volume. And if I try to use Explorer or something, I won't be able to access that because Explorer only accepts normal sort of DOS name, that is symbolic links only. So it won't accept something like this. Now, one way of trying to do that is to use a tool that Windows has, which is the disk management tool. So here's the disk management tool that shows you the list of all the disks that you have and the volumes that are partitioned within each one of these disks. And so I can see everything that is happening here, but you notice that if I right click, for some of them, if I want to attach some kind of drive letter, I can't. So for some I can, and I can even change a drive letter, but for some partitions, some volumes like this volume here, I can't do that. The tool would not allow me. Does that mean I really can't do that? Well, actually we can try doing that anyway. And so you can see here there's some interesting partitions such as the EFI system partition. This is in fact where Windows actually boots from. And so I would like to attach a drive letter here, but I'm not allowed using these tools. Let's see if we can do that ourselves. So let's go ahead and do that by writing some little code. And in general, what I can do here is, in general, define symbolic links pointing to something. And we can do that with documented Windows APIs, specifically one called define DOS device. So let's create a tool here. Let's call that DDD for define DOS device, for lack of a more maybe appropriate name. So here's what we're going to do here. We're going to include the usual stuff. I'm going to have windows.h and stdio. Increase the font size a little bit. Remove all the junk stuff here. And I would like to accept a few parameters. So we need to have command line arguments here. I'm going to use the Unicode variant. I'm going to use wmain here. So I can use the define DOS device in its better form, that is using the W variant and not the ASCII variant. This is just a good thing to do. It's better performing and more generic. So if we have not enough parameters, we're going to specify the usage for this tool. It's going to be some kind of name. That's going to be our symbolic link and some kind of path that is going to be mapped to. If we have that, we can move forward. So basically, it's about calling the function define DOS device. And define DOS device requires 3 parameters. One of them is a bunch of flags, and the flag that we need here is ddd raw something. So that says that the path we're going to provide in the last parameter should be taken as is without trying to interpret that as a DOS path, like a C: something. So in fact, we don't want that. We want to use the raw names. The device name itself is what's provided using the first parameter of the command line. This should be a drive letter, but technically can be anything. But we want a drive letter here, so we'll be able to access that using a normal file system management tools. And the target path coming from argv2. So if that works, it should return a non-zero value. We can say here is success. Otherwise, something went wrong, and we can say error and just display whatever get last error returns. Let's do that, and basically we're done. Okay, so now let's try it. Let's try to see what happens if we use it. So I'm going to open a command window here. Here it goes. Let me just increase the font to make it easier to see. So let's go to x64 debug and do the D. So here's DDD. Let's take a drive like a Z, why not? Z is available on my system. And let's go to FLTMC and select the volume here. Let's use this volume. I'm going to copy the path like so and hit enter. And it says success. Great. It means that if I move to Z, I might be able to see something. In this case, I can't. Access is denied. That's because this drive that's supposed to have the system partition, the UEFI system partition, is very well protected. We can try to go through this command window, but it doesn't seem to work. It says that something is wrong here. It doesn't see the file, the drive called Z column, which perhaps looks like something is really weird going on here. Let me open Explorer first. So here's Explorer. And you notice that in this PC, now we have a Z drive. It's right here. It even has a kind of name called ESP. And if I double click, nothing happens. I try to open, nothing happens. And that's because Explorer is running with the standard user rights, and this drive is too protected for Explorer to access. But it's definitely there. We don't see it here, and that's kind of weird. But let's see if we can figure out what is going on. So if I go here to WinOBJ here, we can go to the question marks there. We don't see any Z, but we can do a global search to look for Z. And here goes. There is a Z here somewhere, and in fact it is in this directory here under session 0 DOS devices. What we see here are values which are known as the logon session ID for a particular logon session. And this is my logon session ID where this Z is there, it exists. Now you can see these session IDs using various tools. Probably the simplest thing to look at is Process Explorer. So if I look at Process Explorer and one of my normal process running under my user, so say we have our CMD process that we've been using here, and of course we have one running with admin privileges. I want the one that runs with normal privileges. This is what I've used here. If I double click here and look at the security tab, we can see the logon session ID is 41F25. That's exactly the one that's being shown here in WinOBJ, which means that this session ID has this extra symbolic link, which is Z colon, that points to hard disk volume 1. And since I try to do something here from the administrative command window, Z is not recognized, and that's because it's a different logon session. It's a different logon session. You can prove that by looking at the other CMD running with the high integrity level, running as administrator. You can see the session ID is different. It's 41D4D. That's a different number. So if I wanted to map Z colon there as well, I would have to run DDD from one of these kinds of processes running under that logon session. So we can do that, of course. So if I go to, well, I don't actually have to go there, but let's go ahead and take dev. We have temp, and then DDD, and then x64, then debug, and then we have our DDD tool. I can do Z, I can do a different drive, of course, that we have to be Z. Let's use K just for demonstration purposes. And again, we have device, hard disk, volume 1. That was the one we've used. Let's just make sure. Yes, that's the one. Let's try. And it says success. So now we can try to move into K. In fact, we can see that K is accessible. This is the system partition. This is where the UEFI applications used to boot Windows are actually stored. And by default, they're not being mapped into any drive. But we can see what's going on there. I can move to EFI. There's another directory here. Again, I can't use Explorer because Explorer doesn't have enough powers to look inside this drive. We can look at boot or Microsoft, there's stuff there. So this is boot x64 EFI, which is the standard boot application automatically being loaded by UEFI after UEFI is ready to go. This is the thing that boots Windows. That's the name that is provided by the UEFI standard, and this in fact is a PE. So technically we can look at that if we open a tool like Total PE, one of my tools. We can go ahead and do that. So here's Total PE, but in order to properly read that, we'll have to relaunch that with admin privileges, because otherwise we won't have the ability to access this particular drive. So again, we might not be able, but let's try that. Here's K. We're looking at that from the system. We're looking at the partition, system partition through administrative processes, which using that session where K is defined. So I can open that thing. And EFI applications are PEs as well. You can see they have a subsystem of EFI application, and they have all the other stuff that PEs have, although they don't have a normal main application. They have a different one, which is way outside the scope of this particular video. This is UEFI, which is very interesting onto itself, but not really part of what we're doing here. Now, you might be wondering, how can we get a symbolic link into the global 2 question marks directory? Can we do that? And it is possible if the process calling something like define DOS device is running under the local system account. So only the local system account can insert global symbolic links. It also actually requires a particular privilege, which is provided to the local system account. Normal accounts or other kinds of accounts will create something which is local to those logon sessions, like we see here. So Z column exists here, but doesn't exist for other sessions on this particular machine. So hopefully this gives you some sense of how these things work. We can go the other way around. There's the opposite function to define DOS device called query DOS device, which allows you to ask a certain symbolic link what it is pointing to. And this works not just with drive letters, but in fact anything that we find in the global 2 question mark symbolic link and the local symbolic links that are part of the current logon session. And so this is what we have here, and all these things, all these particular values are valid functions to the create file function, and of course that includes the local stuff as well. So if I now take an application and try to open Z column or K column from this particular admin logon session, that has a chance of succeeding. In this particular case, it will not work with non-admin sessions just because this particular volume is very well protected, but in general, it could work if we were to map something different. We can go back here for a moment and look at FLTMC again with volumes and see that indeed we have now this extra mapping that's supposed to exist here, which is the one pointing to our K directory here. But in fact, as you can see, it doesn't really show up here. You can see there's no drive let, and that's because this particular tool only looks at the global 2 question marks and doesn't really go and look at the local logon session. So you might not see everything, but obviously K does exist and is properly interpreted. Same goes for the other session here, but of course in this case we can't run FLTMC because FLTMC requires admin privileges. But Z here does exist. The fact that we can't access it is just the particular partition is inaccessible. Now there's another thing you might want to try out. How can you convert things the other way around? So if you have a path that starts with divides, hard disk volume, whatever, and some kind of path, this is in fact how paths are reported by various native APIs. How can we convert that to the appropriate drive letter to make it easier for users to see if indeed that kind of drive letter exists? So I'm not going to show that. I'll leave that as an exercise for you. If you want to have some fun with these APIs, you don't have to use any native API for that, even though there are undocumented native APIs to perform that conversion, but you can use the powers of query DOS device and some searching to be able to perform this conversion the other way around.